In this video, we're going to look at vector arithmetic. So we want to be able to add vectors, subtract vectors, do scalar multiplication. So if we just first look at vector addition, if we have our first vector, which is the u vector, which is u sub 1, u sub 2, and then our second vector, which is the v vector, v sub 1, v sub 2. And then if we want to find the sum, or sometimes it's referred to as the resultant of the two vectors, then actually all we do is add together the horizontal components and add together the vertical components. So if we have this, we're just going to do u1, u2 plus v1, v2. So here when we have u plus v, we're just going to take vector u in its component form as u1, u2, plus vector v in its component form, which is v1, v2. And again, all we do with this is add the components together. So this is u sub 1 plus v sub 1, and then u sub 2 plus v sub 2. Graphically, we can look at this two different ways. This first one here is called the tail to head representation. So we take our first vector u and then we put the vector v onto the end of that. So we put the tail of this vector to the head of vector v, or vector u, sorry. And then we draw a vector from the beginning of u to the end of v, and that is what we refer to as the resultant vector. The other representation over here is called the parallelogram representation. So here we keep both of the vectors in standard position so that their initial point is at the origin. And then we draw in the two parallel vectors. So this one is parallel to v and this one is parallel to u. And then we've got this parallelogram, and then this is the diagonal of the parallelogram, which is also the resultant vector. They're essentially the same things, you're just kind of looking at the visualization differently. Okay, so the next thing we want to be able to do is what we refer to as scalar multiplication. So if we have a vector, so u1, u sub 2, and k is just going to be a real number. So if we want to take that scalar value k and we want to multiply it to the vector, so here this is going to be k times the vector u sub 1, u sub 2. And here all we do is take the scalar value and multiply it times both of the components. So this is k times u1 and k times u sub 2. If you want to kind of visualize that, this scalar multiplication is a stretch or shrink of the vector, and then if that scalar value is negative, then that's going to have the vector point in the opposite direction. So if we start here with u, 2 times u is double the size, 1/2 of u is going to be half of the size. If we do negative 2 times u, it's going to be double the size of the original vector, and then notice it's pointing in the opposite direction. So that scalar multiplication is really just a stretch or a shrink of the vector. All right, so next if we look at vector subtraction. So again, we have our two vectors u and v, and here we want to find the difference of the two vectors. So here, if we just kind of think of this, we've got u sub 1, u sub 2 minus v sub 1, v sub 2. So if we just do a little bit of arithmetic here, we can change this u sub 1, u sub 2, and make this plus a scalar value of negative 1 times the v vector. And then we can do the scalar multiplication. And this would be negative v sub 1, negative v sub 2. And then I can just do my addition, and I would get u sub 1 plus negative v sub 1, and then u sub 2 plus negative v sub 2, which we could rewrite as just u sub 1 minus v sub 1, and u sub 2 minus v sub 2. So really, if we just go straight from here to here, we can see that if we're subtracting vectors, we just need to subtract the horizontal components and subtract the vertical components. Again, if we look at this sort of as a visual, here we're taking a and subtracting b from it. So remember, if we were adding this, we would just draw in this resultant vector here, and this would be a plus b. But since we're subtracting, what we have to do is take b and make it point in the opposite direction. So that's my scalar value of a negative 1 times the b vector, sorry, and then we can do the resultant vector. So this green vector is the a minus b. All right, so if we look at a couple examples here, we've got the vector u is negative 1, 3, and vector v is 4i plus 7j. So what I would do right here is just change this into its component form. I find it easier to work in component form. I find it easier to work with vectors in component form, so when I'm given a vector in the linear combination form, I usually just rewrite it. So we're going to perform the calculations and we're going to give our answers in the linear combination form and the component form. So here if we're going to do u plus v, we're going to do negative 1, 3 plus 4, 7. So remember, when we're doing addition, we're just going to add the horizontal components and the vertical components. So I'm going to have negative 1 plus 4, and then I'm going to have 3 plus 7. So this is going to give me 3, 10. So remember, that's in component form. It also asked me to do my answer in the linear combination form. So in linear combination form, that would be 3i plus 10j. In B, we're going to do 2 times u minus v. So we're going to go 2 times the vector u minus the vector v. Again, I'm using the vector v in its component form. So follow order of operations just like you would with real numbers. So multiply and divide before add and subtract. So we're going to do this scalar multiplication first. So this is going to give me negative 2, 6. And then minus the 4, 7. So this is going to give me negative 2 minus 4, and then 6 minus 7. So this is going to give me negative 6, negative 1. And then again, if I write that into its linear combination form, we're going to go negative 6i minus j. You can do minus 1j if you want. Next, we're going to do 3 times u. So this is just 3 times negative 1, 3, which is going to give us negative 3, 9. So component form, and then in linear combination form, we're going to do negative 3i plus 9j. Finally, we're going to do 4 times v minus 5 times u. So we're going to go 4 times v, which is 4, 7, minus 5 times u, which is the negative 1, 3. So again, remember, we're going to do the scalar multiplication first. So this is going to give me 16, 28. Minus negative 5, 15. You could have distributed the negative and changed that to a plus sign if you wanted. So then this is going to give me 16 minus negative 5, or 16 plus 5, and then 28 minus 15, which will give me 21, 13. So remember, that's my component form. If we write it in the linear combination form, 21i plus 13j.